Hi friend, welcome back to Edupedia world. In the previous lecture we saw the conservation of energy and the degradation of energy. In this lecture we will solve numericals on conservation of energy and degradation of energy, and we will see those concepts in a much clearer sense while solving the problems. Let us start with the numericals. The first numerical states that a ball is dropped from 20-meter height and the mass of the ball is 1 kg. We have to find the velocity when it reaches the bottom and the kinetic energy at the lowest point. We know that the height is 20 meter and the mass is 1 kg, and the initial velocity, the velocity at the highest point is equal to 0 meter per second. We also know that the gravity is 10 meter per second square. Now we can find the velocity at the lowest point by using the equations of motion, but here we are going to use the law of conservation of energy to find the velocity at the lowest point. Now how to do that? If we assume that the potential energy at the lowest point is 0, potential energy lowest point, let me write it as L, is equal to 0 joule, and we can find the potential energy at the highest point at H is mgh, which will be mass is 1 kg, gravity is 10, and height is 20 meter, so that is 200 joule. And since the velocity is 0 meter per second at the highest point, the kinetic energy at the highest point is 0 joule, half mv square or half mu square, u is 0, so 0 joule. Therefore the total mechanical energy, let me write it as TME, total mechanical energy at the highest point is 200 plus 0, which is 200 joule. Since there is no air resistance, the total mechanical energy will remain conserved. Now, yes, we know that the total mechanical energy at the highest point is 200 joule, so total mechanical energy at the lowest point will also be equal to 200 joule. And total mechanical energy is given by summation of potential energy at the lowest point plus kinetic energy at the lowest point. We have taken the reference potential energy at lowest point as 0. So we can write this as 200 is 0 plus kinetic energy at the lowest point, which implies that the kinetic energy at the lowest point is 200 joule. This gives us the answer for the second part, that the kinetic energy at the lowest point is 200 joule. Now using this value of the kinetic energy, we can determine what is the velocity at the lowest point. How can we do that? We know that the kinetic energy is half times mass into velocity square, and since this is kinetic energy and we know that its value is 200, so this will be equal to 200. We can replace mass, which is 1, and this will leave the only variable as the v, which is the velocity. Now v square is equal to 400, so we get that the velocity at the lowest point is root 400, which is 20 meter per second. So we have found the velocity at the lowest point as 20 meter per second. We have found the kinetic energy at the lowest point as 200 joules. This was a simple example to brief us about the concept of conservation of energy. Now let us move to a little more tricky problem. In this numerical, we are said that we have a ball which has a mass of 20 grams and it is thrown up with an initial velocity of 10 meter per second. So a 20-gram ball is thrown up with 10 meter per second and we are asked to calculate the maximum height reached if there is no energy loss. This is part 1. There is no energy loss. What is the maximum height? And part 2 is the maximum height reached if there is 50% energy loss. This third and fourth part are actually not related with maximum height. They are separate questions. We have mass as 20 gram. We need to convert it into kilogram. That will be 20 by 1000 and that is 0.02 kilogram. We know that the initial velocity, let me represent it by u, is 10 meter per second. And we are asked to find the maximum height reached if there is no energy loss. So what this means is that the initial kinetic energy due to the 10 meter per second speed will be equal to the final potential energy due to the height attained. So let's first calculate the initial kinetic energy. I will write it as kinetic KEI, and that will be half times mu square. Half, I will leave m as m and u square is 10 square. Now this kinetic energy, which is at the lowest point, will be equal to the potential energy at the highest point. Now potential energy at the highest point, let me write it as H, will be given by mgh. You can see why I left m as m, because there is a m in potential energy too, and when we equate this two, the m will cancel out. So there is no need to put it into the calculation and make the calculation more complicated. We can leave those m's in as m. Now m, the question says that g is 10, so I will put it as 10, m multiplied 10, and we need to find the h, so that is h. By conservation of energy, this and this will be equal. Therefore half times m times 10 square is equal to m 10 times h, which implies I can cancel this and this, and this will cancel this. This implies that the maximum height is 5 meter. So if there is no energy loss, then the maximum height reached is 5 meter. Now let us see what if there was a 50% energy loss while going upwards. We can use the same initial kinetic energy expression as kinetic energy initial is equal to half m into multiplied 10 square, this many joules. These units are in joules because this is the SI unit, everything is in SI unit. Remember to put it over here. But now the question says that 50% of the energy is lost. So finally, when we are at the maximum position, we have only 50% of the initial kinetic energy available to us. So how much kinetic energy will be available, or how much energy will be available? Energy available is equal to half of half m into 10 square. And this energy, the available energy, will be equal to the potential energy at the height h, which will be mgh, and that is m times 10 times 8 joule. And this potential energy I will equate with the available energy, which is this, and that will give me half times half of m into 100, 10 square is 100, that is m into 10 into h. I will cancel m and m, 10 and 10, so it is basically h is equal to 10 by 4, and that is 2.5 meter. So when a 50% energy loss takes place, the maximum height reached will be reduced by 50%. Now we have got the kinetic energy, we have got the maximum height for these two cases. Let us see the third part, which says what is the velocity when it comes back and if there is no energy loss. If we remember the conservation of energy, we saw that the energy can neither be created nor destroyed, and if there is no losses, then the sum of potential and kinetic energy should be equal, right? So the total mechanical energy should be conserved if no energy losses takes place. Therefore, under the initial circumstances, the potential energy initial, when we are throwing it upwards, then the potential energy, I am taking that as 0 reference, 0 joule. Finally, also the ball comes back to the same position, so the potential energy final will also be 0 joule. Now kinetic energy initial is half times m times 10 square, half mv square, and kinetic energy final is to be found out, that is half times m times v square. This v is to be found out. Now by conservation of energy, since there is no energy loss, potential energy initial plus kinetic energy initial should be equal to potential energy final plus kinetic energy final, which gives us 0 plus half times m times 10 square is equal to 0 plus half multiplied mv squared. Now we can see from here clearly that the final velocity when it comes back is v is equal to 10 meter per second. So if there is no energy loss, then the velocity will also remain same at the same point, because at the same point the potential energy is same, so the kinetic energy has to be same. As a result, the velocity is same. Now the final part of the question asks us to find the velocity when it comes back and there is 75% energy loss. I will do it over here. This will not take a lot of space. So the fourth part says that there is a 75% energy loss. So 75% energy loss from what? From the initial potential plus kinetic energy. Therefore, the final potential plus kinetic energy will be 25% of initial. Therefore, what we can do is we can write the total initial potential, that is 0, plus kinetic energy, that is half times m times 10 square, and 25% of that, 25 by 100, that is equal to final potential energy, that is 0, plus final kinetic energy, that is half mv square. Now what this gives us is that we can cancel out m half, and we get 10 square divided by 4 is equal to v square, and this will give us v is equal to 100 by 4, that is root under 25, which is 5 meter per second. So we see that for an energy loss of 75%, the final velocity at the same position became half of the initial velocity at that position. So if there is an energy loss, we cannot directly equate conservation of mechanical energy and say that total potential energy plus total kinetic energy will remain conserved because there is an energy loss. Hopefully this question gives a lot of insight into the conservation of energy and also the degradation of energy, and when we can apply conservation of energy, when we cannot apply conservation of energy. Let's see another example now. This question says that the power of a pendulum is 1 kg and the maximum vertical height from the mean position is 20 centimeter. Now we have to assume that there is no frictional losses and that gravity is 10 meter per second square. So what will be the total mechanical energy, assuming that potential energy at the mean position is 0? Why is this important? Because if it is not given the potential energy to be 0 at the mean position, we cannot really calculate total mechanical energy, because potential energy is basically a reference with respect to which potential energy at other points is calculated. But if it is not given in the question, then we will assume that potential energy at the mean position is 0. Most of the questions you won't find this assumption provided. So let us start this question. We are given that the mass is 10 kg and it is said that the height, maximum height, is 20 centimeters. So the height is equal to 20 centimeter, which translates to 20 by 100 is equal to 0.2 meter. And we know that at the maximum height, the velocity at maximum height is 0, because if it had some velocity, then that would not have been the maximum height. It would have gone further up. So the velocity at the maximum height is 0 meter per second. Therefore, the kinetic energy at maximum height, these are the maximum heights, is half times mu square, which is 0 joule. The potential energy at maximum height is mgh. Since the reference is 0, so it will be 0 plus mgh, that is mgh itself. And mass is 1 kg. Gravity is provided as 10 meter per second square. And we know that the height is 0.2 meter. So it is 2 joule, the potential energy. Therefore, the total mechanical energy, what is mechanical energy? Mechanical energy is just the summation of kinetic energy and potential energy. Therefore, total mechanical energy is kinetic energy plus the potential energy, which will be equal to 0 plus 2, which is 2 joule. So the total mechanical energy at any moment will be 2 joule. Why so? Because there is no frictional losses. So the mechanical energy will remain conserved throughout. Now we will exactly use this idea to solve the second part. which says find the velocity at the mean position. So we know that the total mechanical energy is 2 joule. Therefore, mechanical energy at the mean position is also equal to 2 joule because of the conservation of total mechanical energy, since no frictional loss is there. Mechanical energy at mean position is 2 joule. We already know that the potential energy at the mean position is 0 joule, that is the reference. Therefore, the kinetic energy has to be 2 minus 0, which is 2 joule again. So the kinetic energy at the mean position is 2 joule. Now we will use the relation of kinetic energy is equal to half times m times v square to find the velocity at the mean position, and this will be equal to 2 joule, this 2 joule, which implies half mass is 1 kg, so I'll write it as 1. V square is equal to 2, which gives V square is 2 cross 2, which means V is equal to root under 4, which is 2 meter per second. So we see that the velocity at the mean position is 2 meter per second. And we already know that the velocity at the mean position is the maximum velocity a pendulum has. So the question might have been framed a little differently, and it might have asked us to find the maximum velocity possible. You need not be confused then, since the maximum velocity is at the mean position, so the question indirectly asks us to find the velocity at the mean position. Now the scenario would have been a little different had there been frictional losses. Then the velocity at the mean position would have been less than 2 meter per second. With this question, I will conclude today's lecture. In the next lecture, we will see about different forms of energy, and we'll see some examples of conversion of one energy to other energy. So till our next class, have a great day. Goodbye.